Okay, so some slightly more complex examples. They're essentially all asking you to do the same thing, just some of them have some extra steps. So with an example like this, one's tempted to work with just the left-hand side, but at the end of the day we need a full quadratic equation. So one of the steps you've got to do beforehand, and you've done this many times before, is you just got to get everything onto the left-hand side, make it equal 0. Okay, so in doing that, I'm going to end up with 4x squared plus 3x. Okay, so that's that one worked out. And then I'm going to put my p on the left hand side, so it's going to be plus p equals 0. So now I've got a full quadratic. Yes, I don't have exactly what p is, but that's part of the question, is to say, well, what would p have to be to get real roots or non-real roots? So we need to remember our theory about those two, and then we can answer at the end. Okay, so there's 3 steps. There's first of all getting it into standard position, and then there is working out delta, and then there's dealing with this whole what can p possibly be. Okay, so then delta equals b squared minus 4ac, okay, which is going to be 3 squared minus 4 times that 4 times my p. Okay, so I've got 9 minus 16p, and that's as far as I can go right now. So the thing is, I can't actually make a statement about the roots. It's being asked the other way around. I'm being asked, for what values of p will I get real roots? Okay, so do you remember what real roots will give you? Real roots means you've got to have delta being positive. So let's create an inequality, because p could be more than one number now. Hey, so let's just say, so delta for real roots, okay, delta must be positive. So delta, which we've just worked out, must be greater than or equal to 0. Okay, so that means that 9 minus 16p must be greater or equal to 0. So you can see what we're actually solving now is another inequality. So we're now just going to solve for p, basically. Okay, so if I leave 16p here, and move my 9 across. Okay, now I'm going to divide through, sorry, the 9 must be negative on the other side because I've moved it. Remember, if you divide through by a negative, which is exactly what I'm going to do, you're going to end up changing this sign. Okay, so this one needs to then go like that. Okay, and I'm going to divide through by negative 16. So I'm left with p on that side, and I've got 9, I've got negative 9 over negative 16, which cancels. Okay, so that means p is anything less than or equal to 9 over 16. That's my answer, guys. They said, for which values of p will this thing have real roots? Well, as long as p is less than or equal to 9 over 16, so on a number line, I can say that is 9 over 16, and p is anything less than or equal to, so a solid dot, and it goes in that direction. Okay, I haven't quite finished this yet, because I also need to say when it has got to have non-real roots. Now, for non-real roots, I know that delta has to be negative, right? And I can fit this in because I've actually done most of the working out already. So that means, so that was question A. For question B, I know that this delta must be negative. So delta must be less than 0, okay? Which means that 9 minus 16p must be less than 0. So I'm going to head off with the same thing. So there I had p is less than or equal to 9 over 16. If I do the same calculation, I'm going to also be dividing through by a negative when I move things around. So I'm going to end up with p being greater than 9 over 16. Okay, so on the number line it'll be the same thing, excepting it'll be excluded. Hey, so if I say that's 9 over 16 and it's excluded, okay, p must be anything greater than that. Okay, these ones are about interpreting the language. So this says calculate the values of m. So we must remember that it's m that we're trying to find, okay, not x. And they say then for which this equation, okay, and then there's 3 different scenarios. One root with a value of negative 2. Okay, so what is the root of a quadratic equation? This is the x value. Alright, so complicated as this might sound, they're telling you x is negative 2. So what do? We know that x is negative 2 because they've just said it has one root, okay, of that has a solute that is negative 2. So that means that we can sub it in. Okay, so now I can say negative 2 squared minus 3 negative 2 plus 5m, which is the thing I'm trying to find, and they've given me this equation equals 0. So I'm solving for m, basically. Okay, so this is 4, that's positive 6, and I've got 5m, and that equals 0. So 5m equals, on that side, it's going to be negative 10, so m is going to be negative 2 as well as x. Okay, so you can see that something that sounds a bit strange is actually asking for something pretty simple and straightforward. The trick here is knowing what to do and understanding the wording of the equation, because they're quite limited. There's only so many things they can ask with nature of the roots, so get used to the different ways in which it's asked and you'll be fine. Okay, so for B, they want to know when it's equal roots. Okay, so equal roots, and again it's about calculating the value of m. For equal roots, we know that delta equals 0. So there's my equation with my ABC in it, and so I know that for equal roots, delta must equal 0. Okay, so I know that delta equals 0 for equal roots. In fact, let me just write it down. You are welcome to use as many words in your answers as you like so that you can decode and help yourself and whoever's marking your paper understand. Okay, so delta is, I'm going to put what delta is here, and I'm going to make it equal 0. Okay, so we've got b squared minus 4ac, so it's going to be negative 3 squared minus 4 times 1 times 5m. I'm going to say that equals 0. Okay, so it's going to be 9 minus 4 5s 20, 20m. That equals 0. And again, I'm finding the answer for m. So it makes perfect sense that I'd have a variable that's m in this particular equation. Okay, so now I've got 20m, negative 20m, and that's going to be negative 9 if I move it. So m equals 9 over 20. Okay, so again, it sounds a bit strange, but actually all I'm doing is making sure that I remember that. And so then I make delta, whatever it is, I figure it out, and I solve for m. And they all have that sort of pattern to them. Okay, real roots. Remember that real roots is just positive, so now I'm going to have that number line idea. I'm going to have a little bit more than just one answer. Okay, but you can shortcut it from the answer you've just gotten, because here I made them equal to 0. So for C, I'm just going to do a shortcut here. Here I had this. I had m is equal to 9 over 20. Now, at this stage of it, if I was making this positive or equal to 0, so at this point here, so let's just say I've worked it out, and I've got 9 minus 20m, and it's greater than or equal to 0. Okay, and then I start moving things across here, right? Now I'm going to divide through by negative 1, like in the previous example. So I'm going to have to change that sign that way around, and I'm going to have m is 9 over 20, because I've divided through by the negative. So that means m's on a number line. So if I have 9 over 20 there, we just know that m is anything less than or equal to, so it's a solid dot, than 9 over 20.